Hey, good morning, Jim.
Morning.
Morning. So I have this coin faucet project that I'm working on, and um, um, just looking to get some critiques on style and convention, and maybe I feel like I'm incrementally making progress. Uh, Enormous hat tip to Rchain status and all the things that Michael Birch has put together, but just maybe. Some cliff notes or some way to just cut through any illusions I have about the way to structure code.
Yeah, do you wanna share your code, Chris, and we'll take a look?
Yeah.
So you checked out the Rchain status Dapp, huh?
Yeah, absolutely.
Awesome. Glad to hear that people are looking at that.
Okay, so let me
How's CryptoFX treating you?
it's great to just do some real quick syntax checking, and then I end up putting it into a command line. I'll end up putting it over here in a command line so I can see it run. But I really am liking it. So what we're looking at here is actually I've got a better view of this. Let's see. So I kind of went through some of the contracts by Michael Birch just to look at general structure. Let me make it a little bigger. And so he had Mint was one of the contracts that he had put together, and he also had Basic Wallet. And so plus is a public member, minus is a private member, and equals is essentially like an object notation. So Mint contains this idea of make purse, and then has an internal make purse, and it makes a purse. And the purse has a certain amount of functionality. And then Basic Wallet, same thing. It's a little bit flatter though. And then I'm trying to do this thing called coin faucet, where there are two major components to a coin faucet. There's the person that creates coins, and there's the person that receives coins. So there is some overlap with Mint and Basic Wallet. But you can see I've got a lot more hierarchy in the way I was thinking about it. And I wonder if that's wrong. If it's supposed to be, you get one level, and anything beyond one level is essentially private. You can't see into this. And unless you expose it through a top level method or function. So like with Mint, make purse creates this internal purse object and all the functions that go along with it. You don't actually get access to a purse creator or something like that. You get access to a top level make purse function. And so down here, you'd see like, I was thinking, well, can I register a coin creator? And that makes a coin creator object, and a coin creator object has a create function, and the create function creates a coin. Was I getting way off the reservation?
Yeah. Okay. Cool. So let's give everybody a little bit of context here. So coin faucet, this one at the bottom is your project, right, Chris? That's what you're looking to design.
That's right.
And then these top two, Mint and Basic Wallet, are things that that Michael Birch wrote that are already in the Rchain ecosystem, and you're basically looking to see what you can learn and compare your stuff to their stuff, right?
That's right.
Okay, yeah, cool. So those top two, Mint, that contract is going to be used for the actual rev on Rchain, and it's a pattern that anyone can follow to make an ERC20-like token. And then Basic Wallet is a contract, and there can be lots of different styles of wallets, but Basic Wallet is the one that the original rev issuance is going to use. So like when your rocks get converted to revs when we launch the network, everyone will have a Basic Wallet that they can keep their coins in, or put them into a different kind of wallet later. And so then, Chris, your question is basically like, hey, I'm jumping in here, and I had this design in mind. I noticed mine gets a lot more deeply nested than any of the examples. Is that okay? Is that right? Or
Right.
Is that the best thing to do?
Right.
Yeah, cool. So why don't you give us some context about the final user experience? Like what's this Dapp ultimately going to do? And then maybe show us some Rholang code.
Yeah. So there's a blog post where you have, let me make this a little bigger. You've essentially got two parties and a Raspberry Pi in the middle. And so let's say a coin creator, a business owner, is going to tell the Raspberry Pi, the Rchain node on the Raspberry Pi, make me a free beer token. And I want you to drop it onto a customer's phone once an hour if they're inside my bar. And then, so they're going to load this coin faucet with a new coin they've created. And then the coin faucet is going to disperse it to people's phones, to a receiver once an hour. And the receiver can transfer it back to the coin creator when they want to redeem or they want to spend it. So that's that. This is the. Let's see if I can make it bigger.
Can I ask a quick question, Chris?
Yeah.
So the idea of creating the token, that doesn't happen every time you run this wallet. It only happens the first time, right? Because that you've already minted your store of tokens.
That's right. And they could say, well, we also want to do free cheese fry tokens or something like that. These are essentially coupons or loyalty points or something like that. So they could say, we're going to issue 1,000 free beer tokens and just drop one an hour. But later on, we want to do a different promotion. So we'll do a different token for that.
Okay.
Okay, cool. So the business owner is going to deploy this contract to Rchain, and there's an Rchain node running on this Raspberry Pi. When the business owner deploys the contract, there's some finite supply of tokens created at that time and never again, and then he just gives them out to customers, or the tokens are more like minted and burned, like he creates one whenever he feels like it and they get burned whenever a customer spends one.
They're minted all at once, probably, just for simplicity, and then they just get leaked out to customers, and they get returned to the owner, who will put them back in the Raspberry Pi. So it's like a perpetual supply, or it's a fixed supply that will continuously go in a circle.
Yeah, got it. That makes sense. Okay, cool. Show us some of your Rholang code. Let's see what we can learn here.
Okay, so at the top, we have the coin faucet contract, and then we have two top-level functions. One's called register creator, which would be the business owner, the person that's going to create the free beer token, and then register receiver. A receiver is a phone, a customer.
So if I'm the business owner, if I'm open, maybe I've got this new business idea. I'm going to open up like Joshy's bar, and I like your idea for this Rchain based like reward system. So I would then call that top level contract on line 3, coin faucet, to like set up the one of these for my bar. Is that right?
That's right.
And then what do I pass in there? What is coin faucet controller? Some unforgeable name that I made?
Yeah, some identifier. I can go either way on that. I could take that out and have it created internally. But yeah, that's essentially what it would be. You pass in some name you created.
Yeah, I got it. So I let's dwell on that for a second, because I thought that was an interesting point. You said, Chris, you were saying either the user can pass in coin faucet controller, like maybe, so I'm starting my bar, maybe I can do like new Joshy's bar in, and then I call up at coin faucet and I give it that unforgeable name Joshy's bar and some return channel. Or I could just call up at coin faucet and it would make the new unforgeable name and give it back to me. And either one of those would work, right?
Right.
Yeah, so Michael Birch, I had asked him about that exact same thing, and his answer there was like, yeah, both of those are great. I tend to prefer the one where the contract makes the new name, because that way we're not adding capabilities to something that already exists, but that's really a matter of taste.
I see.
Yeah, so nice. I'm glad that came up.
And so the way, if I was going to take this out, it would
Can you repeat that, Joshy?
Yeah. How about so? Anybody else want to try to repeat that to make sure I did a good, clear job?
Am I frozen?
No, we got you, Ned.
Okay. Sorry. Could you repeat that last thing?
Yeah, I wondered if anybody else wanted to try to repeat that to see
Oh,
if it was making any
yeah,
sense.
I got it. So for the creation of the return channel, either the caller could create a channel and pass in the channel name, or the design of the contract could be such that the contract creates it and returns back to the caller the unforgeable name. And either is fine. It's a matter of preference. Um, Michael was saying that since Rholang already knows how to create an unforgeable channel, that you could just use that. But Joshy, I was curious of whether you had an opinion about which was the correct or preferred way.
At first I didn't, and then this is probably just me like having a social attack done on me. Once Michael explained that he liked it when the contract creates the new unforgeable name, I was like, oh yeah, that makes sense. I'm going to do it that way.
That was my thinking too, because everyone can inspect the code, or you can test it once and know that it's going to be less likely to get attacked on chain versus whatever your client's doing.
That's a great point. The one sort of practical thing I will say is since I've been writing dApps in the meantime, in this state where our node is like not done yet and not all the features exist, I've been doing it more the way where the caller passes in an unforgeable name, the way Chris had this a second ago before he changed it. Yeah, the way it's going back to. And the only reason that I had done it that way is because when you interact with these things from off chain, you can just pass in a string and that will be like your public name that this thing lives on. So that's definitely not like what you want to do in the long run, but when we don't have a name registry or anything yet, I found that just to be pragmatic. So
makes sense.
Yeah. So Chris, now you've got, this is looking pretty good now, right? So in the new design on line 3, if I've opened up my bar, and so I call @coin_faucet and I just give it some ACK channel. And so then on line 5, your contract actually makes the new unforgeable name itself as opposed to me making it and passing it in.
Right. And then a little bit of output statements, and then it's got two high-level functions. Register the creator, which would be the Raspberry Pi, and some identifier for it, or register a receiver, and that would be a phone ID. And each one of those is supposed to make their own object. Like there's a coin creator object and there's a coin receiver object. And this is similar to the idea that a mint can make a purse. So in this scenario, a coin faucet can make a creator and a coin faucet can make a coin receiver.
Cool. So Chris, I've got a question for you too. On line 3, we've seen contracts that look like that a lot. You've basically done like @coin_faucet. You just quoted that string literal to make your contract name, right? But the contracts on line 10 and on line 92, those look a little bit more complicated. So what process are you quoting there, and how can I read that line?
I'm saying that this is an object capability for the coin faucet. So the coin faucet has the capability to register creators and register receivers with some amount of parameters. Yeah,
cool. And so then the square brackets there, those are a list, right? A Rholang list.
Right.
And so in the process that he's quoting to make this contract, instead of just being like @coin faucet or something simple like that, it's at a list, because you can quote any Rholang process, including a list or a string or a number or something fancy like a map or something like that. And so the idea here is, in order to call these inner contracts, the one on line 10 and on line 92, you have to know this unforgeable name, this coin faucet controller. That's the key that you need in order to call this thing. And then the second thing that he has highlighted, the register creator or the register receiver, that's just how you know like which one you're calling. So the first part gives you security so that only the bar owner can call these things. And then the second part is just which one you want to call. Did I read that right, Chris?
Totally.
Okay, cool.
Is coin faucet just the name though? Coin faucet controller, that's just the name. And then once I know that string, I can actually call that.
It'll look like one of these.
Okay, so I actually have to know the hash of that or something. Okay.
So yeah, so you can see how it says unforgeable right before he's got that hex code highlighted.
Yep.
That means it's an unforgeable name. So question for the audience: can anyone see in Chris's Rholang code where he actually made that unforgeable name?
It's in the new essentially.
Yeah, bingo. Line 5. That's where we got that thing.
Yeah.
Yeah. So
see.
Ned, that coin faucet controller, that like security token or key that only lets the bar owner use the coin faucet, that's an unforgeable name that he made on line 5.
And that happened just because I put new in front of it.
Bingo. Yep.
Does that mean it stays on the R node server? So once you deploy the contract and then that runs, that goes into the R node tuple space.
Yeah, bingo. And by default, the only place you could have that new name is inside the curly braces from line 5 to, it looks like they end on line 149. Or no, sorry. Yeah, that's right. From line 5 to 149. Yeah, bingo.
Okay.
But Chris did something interesting and kind of, common. On line 148, he actually passed a reference to coin faucet controller back on that return channel. So now coin faucet controller exists everywhere from line 5 to 149, plus wherever he just sent it on that return channel.
Got it. So you started. So line 10 is the first argument there is a collection, and so why was this not just simply a concatenated string or something like that? Is it?
I was hoping that I was using a notation that I've seen in other places that would maybe make it more readable or make it.
No, it's cool. I don't have a critique. I'm just trying to understand. So cool.
Yeah. So the idea there is that not anybody should be able to call like register creator. Like Joe Blow shouldn't be able to have these devices that create Chris coins, right? Only the person who made the coin faucet should.
Okay, got it.
So part of that name he's calling is that unforgeable name, that coin faucet controller. So only the owner of this coin faucet should have that unforgeable name.
Okay, so yeah, so in conventional programming speak, the method names are unique. Each method name is unique in addition to the contract instance.
Yeah, bingo.
Is that a good analogy?
Yeah, I think so. He's basically like putting two methods on this coin faucet. One is register creator and one is register receiver. And since they're both privileged messages, he's just making sure that only the person with that coin faucet controller can actually call those methods.
Got it.
And so the intention of register creator is to make a coin creator. And so I need to know what Raspberry Pi it's going to use or is going to be responsible for creating the coins. And then this new creator is the channel to pass back the new coin creator that's registered to this Raspberry Pi. And so if I expand this out, you can see that when I say register creator, a little bit of debugging stuff, and then it makes another controller, coin creator controller, that has one function, create. And it passes that reference, this new unforgeable name on that, it passes it back on this channel, the new creator channel. The create function is going to try and make a new token with a name and a symbol and a total supply. And it also wants you to supply a channel to pass back the reference to the coin you just created. So there's a coin creator that has a controller, and then there's a coin that you'd have a controller for. But this is where I'm getting into this nesting. And when I run this, it really only gets to this message. It never gets inside of the create function when I try to call it. So I wonder if this nesting is, I missed the point. You actually can't do that. Like unforgeable names that are nested are not publicly available or something like that.
So Chris, I don't think there's anything fundamentally wrong with nesting arbitrarily deeply. My intuition is that you may have nested deeper than you wanted to, but this is the first time I'm seeing the code, so I don't feel comfortable like saying that for sure yet. But can you show us where you tried to call this and couldn't get inside that? Like you're saying you can't get inside of that new on line 16 or inside that contract on line 17 maybe?
Yeah, that's right. So down below, this is the integration test. So let's expand this out a little bit. So the first thing it does is it makes the coin faucet. Actually, let me move this around so it all matches up. So it makes the coin faucet, and then it's going to register a Raspberry Pi. So it calls the register creator function. Hide a few things so it's not just overwhelming. So it's going to call register creator, and it says Raspberry Pi, and it gets its reference back. And then it says Raspberry Pi was registered. Let's go ahead and make a beer token. And so it calls create, and it passes in a name and a symbol and a supply. And it wants to get back a reference to the new coin it created. And that's as far as it gets. It doesn't ever receive anything back on the beer token or from the coin create. So if I was to run this.
Where did that beer token name get created? Can you show this for just one more second? Where did that beer token name get created? You got one highlighted on like one. Oh, it's way up top there. Okay, got it. So you on line 173, you pass in that unforgeable name beer token, and then you're expecting an acknowledgement back, and then you'll do the next thing. Is that right?
That's right.
Okay, cool. Yeah, show us what you got.
Where does he send to beer token anything? Where does he write to beer token?
I actually never get it back. Down here, I wanted to, or inside of here, I wanted to write to it, but I never get anything back. So it never gets past line 175.
Well, if you never write anything to beer token, that 4 will never be satisfied.
Yeah, during the create, it's supposed to make it for the first time. So during line 173, it's supposed to.
Oh, okay, so in the create,
it's supposed to. Yeah, it's supposed to call this create with all those parameters, and it never does.
And show us that create method again real quick, Chris.
Okay. The create is here.
Yeah, so Jim was asking, like, when do you ever write anything to beer token? So what is beer token called up here? Is that new coin?
That's right.
So in general, this method takes in something that you've called new coin. In your integration test, that's actually a beer token.
Right.
So right there on line 80, you write something to new coin.
Right.
Jim, does that answer your question?
Yep, thank you.
So when I run this, let's make this a little bit bigger. So I'm just starting a new node here on the left side, and I'm going to deploy the coin faucet contract on the right side. Okay, so we can see some of those output messages. It created the coin faucet. It registered the Raspberry Pi with that unforgeable name. It tried to create the beer token, and then it gets to coin faucet controller register creator. It didn't ever create the token. It registered the Raspberry Pi, but it never created the beer token.
So let's look at the code again, see if we can find a little bug somewhere. Where was that last message that printed successfully? It was that one, right?
Yeah, debug register creator. So that would be here.
Okay, so we definitely ran line 12. That's clear because we got the output. Then on line 16, we make a new name, and then the question is like, did we ever actually get into that contract on line 17, right?
Correct.
Oh, okay, hold on. Even if we never successfully called that contract on line 17, we should have gotten something back on new creator from line 86. Is that right?
Right, exactly. And so when that came back, when line 86 came back, that is, I wrote that out to the screen. That's the unforgeable name. So we've effectively registered a creator, and we sent it back on this new creator channel. We sent back the name, the unforgeable name, and I caught it here on line 168. I caught it here, and I said, well, let's just write it out to make sure I got a value. I have a value. I have a coin creator, this Raspberry Pi. And so then
Show
I
us
said,
that output line just to make sure we got it.
Yep, that is here.
Oh, yeah. Oh, got it. Okay, cool.
And so then I said, okay, well, now that I know I've got an unforgeable name corresponding to this coin creator, let's call the create method or the create function on it. And that's where it stops.
Okay, cool. So show us that code up top again, the one that we didn't correctly call. Right. Okay. So we did get that line 86 did send a message. We know that you printed it out correctly. And then you tried to call that contract that's on line 17, right? Coin creator controller and then create. And we think that never got called correctly. Can you show us what's inside that contract? Oh, there's a debugging line. So yeah, so if that contract got called, we should have seen debug, coin creator controller, arrow, create, right?
Right.
Right. So isn't the scope of that name coin creator controller just its parent contract? So it's not going to be visible outside its parent contract?
That's what I'm wondering. Did I nest this too much, and it really does need to be one level deep? I mean, I can refactor this to where it's all one level deep. I just I didn't know.
So we know you created new coin creator controller on line 16, and we know that it got passed back correctly on line 86, right? So that all seems good.
Right.
So I think that's okay, but then the question is, why didn't we end up calling that thing on 17? And so the tip I learned from Dan Connolly, which you've already done, is put a debugging output inside of every single contract in every single for.
Yeah.
So that's good. One thing that I've run into occasionally, because there's not good error messages for this, is that like if you call a contract with the wrong number of parameters or something that will make the pattern not match, that just fails silently. So I see you're expecting 4 params there, right?
And I used a number as one of them. Is
Okay.
that an issue? If
No,
I
that's
quote
okay. Go ahead. Whoever was talking.
I'll quote it just to see if a string makes it happy.
Okay.
Let's just run this again just to make sure there's no syntax errors. And there is. And
Oh, it's really hard in CryptoFX because it always, I think it's right there on 161.
yeah. Let's try that again.
I opened a bug with the CryptoFX team about that line number, by the way. Name context.
All right. Let's restart our node. Let's reload this contract. Okay. Same point. We got to the same point. And so changing it to a string, changing 1,000 from a number to a string didn't help. There's 4 parameters. There's the name, the symbol, total supply, and then an ACK channel, which is new coin.
Yeah, right. Okie doke. So another thing that can go wrong, I don't think it did here, but I'm just sort of saying my ideas out loud in hopes that people will find that helpful. if you had accidentally typoed the method name, like you called your method create, if you had spelled that wrong in one of the places, again, you wouldn't get like a method does not exist or anything like that. You would just get a silent failure. But yeah, it looks like you did that correctly, right?
Well, what I'm thinking is that that method is nested, and so essentially it is not the full name because it's inside of coin creator, inside of a unforgeable name, and it may or may not be public in the sense.
So I think that was my suspicion. And honestly, I'm kind of encouraged to just make it work. So I feel like I'd like to flatten this out because I know top level functions work, and I have no issue with that. And I know that Mint goes one level deeper. They have the ability to make these nested functions, but it's because they created these internal functions from a top level function. So I can't have like a two-step, if I'm going to follow the Mint example, I can't have a two-step process where I create a thing that gives me an unforgeable name that I can call functions on that creates a thing. I just need to have one function that does all that internal work inside the function.
That's my intuition, is that create is private within coin creator. So you have to, I don't know, I'll be quiet, but that's my intuition.
No, that's okay. I'm glad you're talking, Ed. My intuition is that that's better design, Chris. If you can flatten it, you should flatten it. But I don't think there's a fundamental reason why this shouldn't work. I think the computational model is if you know the name of a channel, you can call that the contract on that channel. And I guess by know the name, I mean you have all of the unforgeable names that go inside of it. But here's my thought. This is the most complex Rholang we've looked at during office hours. So what do you think about letting me or someone else spin up a simpler example that uses this same pattern of compound names so we can dive into that?
Totally.
Okay, cool. That's great. I'm glad this came up. I'm going to grab the screen share here. And let's just see what we can do. So I got a new file. And Chris, tell me if this is basically the same thing that you were thinking. So what I want to do is make a car dealership, something like this, new car dealership. And I also know that I'm going to have to print some stuff out here, so we'll do that. And so the idea is whenever you call up the car dealership, you can buy a new car. And you can give it a name. I guess we'll call it this. This is going to be the name of my car. And then I'm also going to need a return channel. Okay. I forgot that's a contract. And we'll fill that in a second. We're not done with that yet because I want to make sure everybody understands the idea. So here's how I want to run this. Integration test basically means here's the code that shows that my other code works, or hopefully shows that it works. So what I'm going to do is I'm going to call up car dealership, and I'm going to buy a new car, and I'm going to call it Joshy's car. And then I have to give some name that I'm going to get my reference back on, and we'll just call it like, I guess we'll just call it ACK. So I need to make that thing. Okie dokie. So what I've done so far is I've called up the car dealership. I said I want to buy a new car and I want to call it Joshy's car. And the car dealership, I haven't coded this part yet, but what it's going to do is it's going to give me back something on this ACK channel. Okay. So once I have something back there, I can listen for that new car to come back. So I'll be like Joshy's car, and I'm going to get it from that ACK channel. And now in here, this is where I can do stuff with my car. So I can only do stuff with my car inside of this scope from line 11 to 13, because that's where I got the reference back. That's where that unforgeable name jcar exists. And so the other thing we'll try to demonstrate here is Eve. Anybody know what Eve means when you call a character Eve?
The evil?
Yeah, she's the evil one. We used Eve in a previous office hour. So she's going to try to steal my car or drive it without my permission or something. And so, you know, she might do her best, something like at jcar drive. And who's driving? Eve. So she's going to try to drive my car here, and I'm going to try to drive my car here. So who's driving? I'm driving. So the goal, if we code this part correctly, and this what we're about to code up top is the analogy to what Chris was doing earlier. What should happen is that I can drive my own car because I have the object capability, this unforgeable name that allows me to drive it. And Eve should not be able to because she does not have permission to. She doesn't have basically like the key to my car. In fact, that's a better.
Well, Joshy,
Yeah.
there's some new syntax. There's a new syntax I can see here that I'm not quite familiar with. Now, you quoted the car dealership in front of contract. May I know why? We already bound car dealership with a new operator. So why are we quoting it again?
Are you talking about this line, David?
No, line 3.
Line 3, this one right here.
Yes. Why do we have an at in front of car dealership?
Oh, great. Okay, great question. So line 1 makes the name, binds the name new car dealership, right? I think that's what you were saying, right?
Yeah.
But so far, only given line 1, I just have an unforgeable name called car dealership. I haven't done anything with it. Like I could send messages on it. I could potentially receive messages on it. So on line 3, that's what I'm doing. I'm receiving messages on the name car dealership. Oh, this, you're asking about this, right?
Yes.
Yeah, now it's correct. I had a mistake before. Yeah, good catch. Does this look better? You still there, David?
Yeah, sorry, I had a network issue for a minute. Yeah, I was asking about the at in front of car dealership for the contract on line 3.
It looks better now, right? Now that I deleted it?
Yeah, much better, yeah.
Yeah, thank you. Good catch. Yeah, I had just made a mistake. So this is better now. Okay. So just to run through the narrative again, I call up the car dealership, I give the car a name. What I get back on the act channel is the key to my car. And then in order to actually drive my car, I need to have this this key. You can't drive the car without the key, and so this is just who's driving here. Okay. So now let's try to do what Chris had done. So inside of the contract, we're going to make a new key. Every time someone calls up and buys a car, we have to make a new key for that car. And then what we do is we give them back the key. And this is another point of stylistic choice. Chris had given back the key as the very last thing in here, and Michael Birch does it the same way Chris does. I like to give back the key first so that the reader, who's usually my future self, remembers like what exactly is getting sent back on return channel. But it doesn't matter. All these things happen concurrently, so you can put it at the beginning or the end or buried in the middle somewhere. It doesn't make a bit of difference. So now I want to build this contract. And this is going to be a compound contract. I'm going to listen on the key. If someone uses this particular key, and they say they want to drive, then here's how driving works. Print. We'll say, oh, and I said that this is supposed to take in a driver's name. So you call up this contract with the key to the car and what you want to do, and then you say who you are. And so here's what I'll do now. Driver is driving car. Okay, so I don't think we've talked about this $sign stuff before. This is called string interpolation, and so I can put different stuff into these fields here. And so the way that we put values in there is like this. The driver is driver. That's what we got in here. It should say Joshy. I passed it in right here. And then the second thing is the car. So what car are we driving? Well, we gave that a name right here. That name. Okay. So that's a lot of code that I banged out all at once. We'll see if it works. Does anybody see any problems or have any questions before we try to run it?
I just had a question about the return name and doing things in parallel. Isn't there then an opportunity that someone would, a caller would use that unforgeable name before the rest of the contract is in place? The key and drive contract is.
Yeah. So you're saying like I gave back the key right away. What if I try to drive it before this thing is successfully built? Right.
So I'm maybe thinking of it procedural in this instead of concurrent, but I'm just trying to understand: is there a race condition?
Go ahead, David.
Okay, the key isn't the key supposed to be quoted? The key inside the return send.
Yeah, this should be dereferenced. Correct. Thank you. Good catch. So, but Ed, that was not your question, though, right?
No, it's just why is this concurrent as opposed to sequential?
Yeah. So everything in Rholang is concurrent. That's what this parallel operator means. It has to be concurrent.
No, I understand, but.
Oh yeah, why didn't I do it sequentially? Like that.
Why didn't you do it sequentially?
Like probably what I wanted to do was build this contract and only then give back the key, right?
Yeah, isn't that a safer?
So that's a great question. And here's what let's consider the bad scenario where someone tries to drive before the key comes back. Let's just think about that for a second. The only place I've tried to drive is something down here, right? I can't even try to drive this thing until I get the key back. So let's say the key comes back first. Like you're right. We don't know. These might happen at the same time, or they might happen in the order I've written them, or they might happen in the other order. So let's just assume they happen in the order I've written them, because that's like the scary one, right? That's the one where I get the key and try to drive before this contract's even.
Right.
Yeah. So let's play that out. I get the key back. I've called it Joshy's key down here, and so here I go. I call this thing and I try to drive. And let's say this contract is not even in the tuple space yet. That thread is just taking a long time, or for whatever reason, it doesn't exist yet. So what happens then is that this send actually goes into the tuple space. Even with the receive not there yet, the send can go in. I think of it like putting a message in a mailbox, and it just stays there until something comes along to receive that message. And so this attempt to drive will just sit there in the tuple space until this contract also arrives in the tuple space, and then they can have a COM event.
So could you say that line, I guess 20 is it's in the tuple space, but so there's got to be some manager, right, of these events that knows when the line 8 contract now appears, right? There's some kind of pump loop, right, that keeps on interrogating and then goes and matches it up, right?
That's basically right, Ned. I don't think it's a loop that keeps polling, though. I think what happens is every time something tries to go into the tuple space, whether it's a send or a receive, the thread that's putting that thing into the tuple space looks and sees whether there's a matching, if it's a send, sees if there's a matching receive, or if it's a receive, sees if there's a matching send. And if there is, then we have a COM event. And if there's not, then whatever thing we just put in just goes in there and sits and waits.
Okay, so that's good. So better way to say it. So when there's overhead associated with things entering into the tuple space.
Yeah, that's right. So you can think of it almost like this. Like, let's say the car dealership, if we map this back to like real world meet space interactions, like maybe when I call up the car dealership, or I go in to buy a car, they give me my key right there. and they're like, all right, we don't have this car on the lot, but we're going to have someone deliver it to your house next week. So here I am with my key and no car to drive. Like, if I do this thing, if I go out to my garage and, like, you know, sit down in nothing and turn a key with no ignition, like, nothing happens. That's okay. Like, it didn't destroy my car or anything. I just can't drive because there's no drive contract yet.
Gotcha.
And so in Rchain, the analogy there is like me trying to drive just gets queued up. It just goes into the tuple space and it sits there, you know, maybe forever if the dealer ripped me off, or until whenever this contract gets built successfully.
But you're saying it's not going to fail silently. That call is still there.
Correct. It's not. This will not fail silently. My attempt to drive just sits in the tuple space and waits patiently until there is a car to drive.
Thank you.
Yeah, no problem. That's a really good question. And and the other thing is, like, even if we do this, like, the way I've written it makes it more clear that there's an interesting question to ask there. But even if I do it in this order, like Chris did, that same question is still a perfectly valid.
Semantically identical.
Yeah, bingo, exactly right. Yeah, that's right. So I just happen to like it this way better. All right, so I'm going to try to run it, and then my node can tell me all the big mistakes I've made here. So I've got a node running. And then, where did I save that? I think on my desktop. So anybody remember the command to run this thing?
We're deploying a contract.
Yeah.
Our node deploy squiggly line / where you saved it and the name of the contract.
Yeah, nice. That sounds like Jeremy.
Yeah. Oh,
Anyway.
so while you pull this up, curious question. So when you technically want to put nil beside Joshy's key drive, and if Eve tries to drive it, so you're telling the contract to do nothing?
If I put a nil in somewhere?
Yeah, where Eve is. So if you already don't want her to drive to test it out because you already paid for the car, wouldn't it make sense to put nil like beside Eve so it won't execute?
I see what you're saying. Okay. So what I'm passing in here when I call this, like, key drive method, this is the name of the driver, and it's only for, like, human readable purposes. It's because what I want to happen is it's going to say Joshy is driving Joshy's car or something like that.
Gotcha.
Or, hopefully we don't see this because it would mean she stole it successfully. But, like, for example, Eve is driving Joshy's car or something like that.
And that brings my next question was, would they be concerned? You just say it will turn the tuple space, but can someone view that and say, oh, I see the contract hasn't deployed yet, and it's Joshy, so I'm going to try to deploy it as well to try to get his car? Does that make any sense?
Yeah, that does make sense, and that's exactly what Eve is trying to do. So spoiler alert, we're going to get some kind of error when Eve tries to drive my car, and the error is basically going to say, this line doesn't make any sense. Eve can't even send this thing because she actually doesn't have access to this key. So we defined that name, Joshy's key, right here in this for loop. And so it only exists within these curly braces. So when Eve tries to do it, it's going to say something like, this free name doesn't exist or something. And so
at compile time.
Exactly, yeah.
So
so let's, yeah, go ahead.
Yeah, I'm still trying to understand why we're returning key.
This
Why do
line
we
we're
have-
talking.
Yes.
Yeah, so when I call up the car dealership, that basically means I'm going to try to buy a car. And I, just for human purposes, I'm going to name my car. But the real interesting part here, and the part that Chris also did, is I need to get something back so that I can use this car. I need to get an unforgeable name back that, like, represents my ownership of this car. Or in his case, it represents, the ownership of this coin faucet so that I can make my beer tokens. And so it doesn't have to be called key here, but I called it key because, like, to start a car, you put in the key and turn it, right? So this key represents my right and my privilege to operate the car. And so I guess to answer your question is, like, whenever you buy a car, you're expecting to get that key. The key, it is. So I'm sending key over my return channel, right? And I called my return channel ACK. this ACK is the same as the return thing. So what I get back on my ACK channel, I'm calling it Joshy's key. So this key that I have highlighted now.
I'm confused now. You said you sent key, right? You returned key.
Yeah, correct.
Then so if they're the same thing, why don't we just call them the same name?
Oh, we totally can. But here's the idea. I up here I want to call it key, just a generic term, because I'm going to make a new key every time someone buys a car. And here I want to call it something specific. This is Joshy's key because this only works for my car. So we could do like, here, check this out. This might answer your question. If I take all of this, so now you're going to buy a car. And you're going to get back your own key. And then using your key, you're going to try to drive your car. With your key, you're going to drive. And let's say Eve doesn't want to steal from you. So this code right here, David, this is you buying a car, and what you get back is a key that only works for your car. Your key shouldn't start my car, and my key shouldn't start your car. So it makes sense that we're going to call these different things, like David's key and Joshy's key, because they go to different cars.
Okay. So what you're saying is this arc, David's key or Joshy's key, consumes the return key send.
Yeah, yes, exactly right. So when when the dealership sends the key on line 5, I'm receiving my key here on line 20, and likewise, you're receiving your key here on line 35.
And those are just tests,
Okay.
right? I mean, technically, you could have put those in another. You could have deployed the first contract and then.
Exactly right. Yeah, like in practice, probably the car dealership contract would be one thing that we just deploy to the blockchain. And then when I want to buy a car, I deploy this part. And then when David wants to buy a car, he deploys this part. That's exactly right.
Yeah. Okay, so what I'm saying is I would like to see how this turns out. Are we doing a deploy or an evaluate?
Yeah, I actually want to do an eval. Deploy is fine too if we want to go on chain, but it runs a little faster if we do this. So I want to do eval. So, but remember, we're probably going to have syntax errors first. Sure. Line 8, column 16. And what was the error? It said.
Oh, because you changed it with the star. We have to put the star at key. Since you're returning it, or would that not matter?
Yeah, so I want to send the process, so I put a star here, but I want this to be on a name. So what was the error message? It says, oh, it just invalid syntax from 8.16 to 8.17. Oh, because contracts have to go on quoted processes. Like that. So this thing here is a tuple. It's a data structure, but it's a process, just like a string would be a process. So to build a contract, I have to listen on a name. I need to quote that thing.
Okay, I didn't get that part.
So yeah, let me get a new file here for a second. You of course know that it's okay to do this. Contract at whatever. And maybe
yes.
It's nothing. So this is all familiar, right? What's not okay is to do this without the @ sign there.
Yeah, but I was thinking this is done because we haven't actually bound this whatever channel, so it's more or less like a free name. So that's why we have to quote it.
The problem is that this is not a name. What is this thing? This whatever?
It's a string.
Yep, and strings are processes. So it's a process. And when you build a contract, you always have to listen on a name, not on a process. So we have to quote it. And so likewise here, wait, where was it? Right. So this thing is a process. This tuple is a process. And so in order to build a contract, we have to quote it.
Okay, but it's just we just have the drive quoted here. We don't. The key isn't quoted. The key isn't a string. It's just the drive that's the string.
So one thing I want to point out, there's two different kinds of quotes. There's these kinds, right? Like the traditional English language quotes. And then there's this one that quotes Rholang processes and turns them into names. And so the quote that I was talking about is this @ sign one. Anytime we have a process literal, which like this is a process literal, let's see, there's a bunch of other ones. Like this is a process literal. Anytime we want to turn those into names, we have to quote them with this @ sign. So here, let me make a table. Here's a process, and then here's a name. So an example of a process is like this, hi. And the name that's built on that thing is @hi. Another kind of process is just this, an integer. And the name that's built on that is this. Another process is this, and the name that's built on it is this one. And then here's a fancy process. It's a tuple. And the way we build a name on that thing is like this. And this last row is what I've actually done in the car example.
Okay, I think that's better now.
Okay, cool. Yeah, thanks for asking about that, David. So let's see if I fixed my error. After all that, I probably still have an error. Okay, name variable key at 49 used in process context at, wait for it, 818. 818 is here. So this is the problem. Okay. David, you're much better at getting those stars and ats right than I am.
Okay, but now I don't think I understood what you just did. We're having double quotes. Okay. This is because David here is a process, so we're turning it into a name.
Other way around. David's key is a name. I created it right here.
Yes, that's what I'm saying. We're turning it into a process here.
Okay, well, that's exactly right. Yep.
And back to a name. Is that what that means?
We lost you for a second there, David.
What I'm saying is, if we're having two quotes in front of David and Joshy's key, it means we're first converting into a process and then enter a name.
Yeah, so Joshy's key is a name. I've converted it to a process with this unquote because in order to make a tuple, you have to have process, comma, process, comma, process, comma, process. So drive was already a process because it's a string literal. I had to make Joshy's key into a process also. And then once I have this whole big tuple process built up, finally I can quote it and turn it back into a name.
Okay, right, yeah.
Yeah. So that's a little, we got a little deep into the weeds, but finally we see the thing we wanted to see, which was this. It looks just like another error, but it actually means something important. Top level free variables are not allowed. Joshy's key on 27.8. So 27.8 is right here. So what did that error message tell us?
There is no receive for that for Eve to steal.
Yeah, bingo. It's saying like, Eve, I don't know what you're trying to drive here, but you don't have a key that's called this thing. Like you can't drive this thing, whatever it is, because you don't have the key to it. So what we saw there is that using this key as an object capability actually worked. It really did what we wanted because presumably I'm able to drive my car and David's able to drive his, but what we just saw is that Eve is not able to drive my car because she doesn't have the key.
Joshy, people are starting to leave. Could you save this program in a file and I'll put a link to it in the document if you do.
Sure. Yeah. That sounds great. So Jim's got the recording, and Gary, maybe I'll pop this on Discord, and you can put it wherever you like.
Thank you.
I know we're a minute over, but we'll close this up real quick by showing what happens when we don't have Eve causing problems. Okay, that looks like it ran, and here's the output. David was able to drive his own car, and I was able to drive my own car. Yeah.
Okay, now there are two things I'm really curious about. I'm curious about how the app channel got to swallow the or consume the return key, and I'm also curious about how the print works.
Oh, great. The print's an easier question. I'll answer that one first. You can call your print channel anything you want as long as you put row IO standard out here.
Oh,
So,
so that's not
the-
necessary.
You're
Okay.
probably used to seeing
The part I was actually concerned about is
Oh, yeah. Go
how
ahead.
it's actually got name. Like, for instance,
This
say
part.
Joshy
You know about
driving
this
his car, and yes, that's what I'm talking about.
Got it. Okay. So you understood the print part, right? Okay. So
Yeah.
here's string literal. Let me show you this first. Let me get rid of all this fancy stuff and run the code again. Whoops. And we'll see what happens. So now it's this probably isn't any surprise, right? I printed out some string literal and it looks just exactly like what I typed in. That's no surprise.
Yes.
The interesting part and the new thing that I did here was I have these couple things that there's always a $sign and then squirrely braces, and inside there's some word. So this is used for something called string interpolation. And it exists in other languages too. So basically what you do is you take this string that has these special $sign and squirrely brace syntax, and then you put 2% signs. That's just the syntax. You always put 2% signs. And then you put a map, and a map has curly braces. So in the map, we put key value pairs of all the stuff we want to sub and what we want to sub it with. So I want driver, that's this thing that I put right here, to be replaced with, whatever, thing 1. And then I want car, that's this thing that I put right here, and I want it to be replaced with, whoops, I need quotes there. Or how about this? I want it to be replaced with the number 1, 2, 3, 4, 5. Okay, so let's see what that does. You can make a guess about what that might do. Thing 1 is driving 1, 2, 3, 4, 5. So it replaced driver with thing 1, like I told it to right here, and it replaced car with 1, 2, 3, 4, 5, like I told it to right here.
Okay.
So now you helped me get it back to how I wanted it. I wanted it to put in whoever's actually driving this thing. So how do I make that happen?
Exactly. That's what I'm trying to understand. So, the way I understand Rholang is Rholang gets to assign names to things. For instance, if we should check the tuple space or the evaluate now, you get to see x1, x0. So I want to know how this Joshy was not bound. It wasn't bound to any particular name. So I want to understand how possible it was for us to be able to interpolate a string here.
Name came in when I very first called car dealership. Oh no, sorry, that was the wrong one. When I call drive, when I say I want to drive the key that starts with my key, I pass in my name as a string literal right here, and that's this thing. That's @driver.
Okay.
So that's where I got that from. Instead of putting some thing 1 or whatever it was, I've just put driver right there. So the way that
Okay,
did
I have to practice a lot of this
on a channel. Oh, yeah, go ahead.
I was just making a comment. I said I have to do a lot of practice to actually get to be at home with this.
Tell me about it, man. I feel you. Yeah. And then likewise, so car, we actually passed it. I should have called this car name or something a little bit better, but I passed it in up top when I first bought the car. And so I just had it like this.
Okay.
And so I think that gets us back to how we were a second ago. Yeah, there's the output. Yeah. So, okay. So anyway, the reason I went into all of this is because in Chris's contract, he had called on this compound name, something about the coin faucet creator, and the method was called create or register or something like that. So I just wanted to show how these compound names work. So.
Okay, so like Gary stated, kindly paste the link to this, and even Chris's code. I can't find a link to that. Is it on Discord?
Is Chris still with us? Maybe not. I'll ping him here and have him post his code. It's probably on GitHub somewhere, but I don't know that for sure.
Okay.
So I'd like to show one thing about order.
Yeah, that's great. Jim, can you steal the screen share from me? I'm a little bit buggy here.
Yeah, I can. Where is it? Share. Seems to be a little bit slow. Okay, this is in the collab, in the Rholang channel. We can evaluate expression here, and here I was listening for the channel cookie, the message, and but I did this before writing to the message, before writing to cookie. So I got evaluating here, but I got no result back from it. Then down below here, I do a persistent write of cookie with 2 bangs. I want a cookie. And then it says evaluating, and now it did the for. It did the write to the cookie, and then it got the result from the for that I did up here. Okay, and
okay,
that's an example of doing something before I define it. And then if I listen on the cookie channel again, because it's a persistent write, I want a cookie again. And this goes back to the early computing, when people put access memory outside their program, and it would insert code that would just say at random points, I want a cookie, I want a cookie.
Nice.
I just thought that was.
Yeah, that's a really nice demo, Jim. I like that you showed, so if I understood right, you put a regular single time listen, then you put the persistent send, and so that original listen got consumed and it said I want a cookie. But It's a persistent send, so the send is still sitting in the tuple space. So then you put another for, and it also received I want a cookie, right?
Right.
And so since it's a persistent send, it's still in there. Like in theory, I could go put one in there right now, and I should also want a cookie, right?
Right.
Hey, that's great. We need faucets like this on testnet, right?
Yeah, definitely.
A cookie faucet.
Yeah. Jim, you once I get a token example together, you can make cookie coin, and then we can all pass it around testnet.
Yeah, we can do a deploy, which I think I already did. And we can do a propose. And propose sometimes takes a long time. Sometimes I have to restart my node to get propose to work. But currently this is running on the dev network.
Yeah. Awesome. Well, guys, oh, nice. That was good.
So we got a block. We created a block. So anybody on the dev network now can listen to cookie, and they'll get I want a cookie.
Nice. That's the dream.
That's the dream.
Real quick, Joshy, so last night I just started working on, I'm trying to give myself some homework assignments.
Oh, great idea.
And so every week I want to see if I can just bring a new smart contract. And right now I'm working on, always whenever someone learning program, they always want to know how to make an ATM application. and I made an attempt that I horribly failed at it after watching the lesson for today. And you pretty much what I want to ask is it best practice to make a testing contract like we did earlier, where it acknowledged, like, for instance, if the pin is not Joshy's pin, then like kick back that error? I think it'll be best practice just to keep doing that before you even build out your contract for almost like a formal verification. I'm sorry, like a certain way.
Yeah, it is a best practice, definitely, Jeremy, to write your tests and then write your code. But I'd be lying if I said that's how it went down in practice. Like, I don't even always do it that way. So, you know, you should write tests either before or afterwards, and before is better, but afterwards is more common. And like, you know, when you sit down to write code, you've got some motivation. You want to do the fun part. Like, don't lose your motivation by being like, oh, I got to write tests first or whatever. So it's kind of up to you whether you write the tests first or not, in my opinion.
All right, and then for the acknowledgement channel, that's not necessarily like hard coded in. So if I just only wanted to send back a go no go, I can just do that by just typing in acknowledge or user acknowledge or whatever.
Yeah, let me make sure I understood what you meant. So like, for example, I'll get that out of here. So like, I sent back the key on my return channel. Are you asking about like the fact that I called this thing ACK?
Yeah, so like, for instance, I want to acknowledge to the user that he was able to sign into his bank account, right?
Yeah.
So it'll be best practice for me to just put acknowledge in the car dealership, you know, bank ATM, then.
Yeah, that's a great idea, right? So like, when you call up a contract, you know, in traditional programming languages, you get to return a value that often indicates whether it's like successful or not. And so in Rholang, the way we do that is you pass in a channel to get an answer on, and it's common to call those ACK or return or success or something like that, but you can call it anything you want.
As long as it can listen in to read on the correct keys of what it needs to, I guess, produce that value.
Yeah.
So like, for instance,
yeah.
right. Oh, I was about to say, so return is on where you see contract car dealership at name, comma, return. That the return is just listening for the acknowledgement that everything is successful, then it will initiate that smart contract, correct?
Close. The return is a channel on which the contract tells the user whether it was successful or not. So when I call up car dealership, when I call this dude up on the phone, I'm like, hey man, I'm looking to buy a car. I got two pieces of information for you. One is what I want to call my car. Like, that's just kind of silly for my toy example. For you, this would be like the PIN. I want to use my ATM, here's the PIN. Or I want to sign up for a bank account, here's my PIN, or something like that. And then the second one is the return channel or the acknowledgement channel or whatever you want to call it. And that's where I'm going to get back some like object capability that shows that I really am the right owner. Or in another example, you might just get back like true if it was successful and false if it wasn't, or something like that.
Perfect. All right, thanks.
Yeah, cool. All right, we're 15 over. Let's wrap it here for the day, and then we can look at whatever you guys bring next week. That sound all right?
Sounds good.
All right, thanks for coming, everybody. I had fun today.
All right, take care.
Bye.
Don't forget to paste the link to the code in Discord.
I will do it right now.
Yeah, I'll also put it in the channel document for a record.
Yeah, where do we get that document? Where is that document located?
It's in the link is in the channel, David. Or is in the Zoom channel.
Okay, how about the video recordings? Where are they on DVDAL YouTube channel?
That's where they're going, yeah.
I did a crappy job the last 2 weeks, David. I didn't get recordings, but now I got Jim helping me, and he's going to get it right. He'll get it up there.
Okay.
Yeah, you still got to accept your manager status in the.
Oh, I thought I did that. Okay, I'm gonna put that on my
Oops, we lost Joshy. There you are.
Lost you there for a second.
Oh,
I think we're going to change the name of that channel. I should have Rchain in there, even although it's used for multiple communities.
yeah, nice.
I accepted board position for Digital Life Collective. I must be crazy. I don't know why I did that. But it's very symbiotic with Rchain in my view. So
Yeah, nice. Good. Thank you for helping out with that, Jim, and sharing your room. I appreciate it as always.
all right, this was awesome, Joshy. Thank you so much for.
Yeah, you're welcome, and thank you guys. All right, I'll see you guys next week.
All right,
All right,
Joshy, are you? Do you have to go to another meeting?
I do pretty quick. I've got one at noon, and I've got some stuff to get ready before that. That's 45 minutes for me.
All right. I was just wondering, what programming style do you feel you bring to Rholang when you write Rholang code?
I just got a message that my meeting might have started 15 minutes ago. So that's my bad. I'll that's a great question. Can you just ask me on Discord and I'll hit that up? I'll hit you up there.
Yes, and put the link to the code you just wrote.
I put the code in Colab already.
Oh, great. Thank you.
Bye, guys.
Bye.